In this short little video, we're going to have a look at the hydrogenation of polyunsaturated plant oils to form margarine. Margarine is obviously a very common substance. Most of us use it in the morning bread or our toast. But how do we form it? Let's start with hydrogenation. Hydrogenation is the reaction of hydrogen via an addition reaction. And the oils that we use there, the plant oils, that refers to probably the most common one is a sunflower oil. Maybe olive oil could be used as well. But let's have a look at this concept of polyunsaturated. Just make sure that we're clear there. The word poly, the prefix means many, and then unsaturated. Remember that we've done this work. An unsaturated bond means a double or a triple bond, a carbon-carbon double bond, or a carbon-carbon triple bond. So polyunsaturated plant oils mean that cornflower oil or the olive oil has a number of double carbon-carbon bonds in its chain. So if we look at a particular type of plant oil, notice I have an R on the end. That means that the chain just continues for a certain number of carbons. But you can see in that chain, this particular one I've drawn has got 1, 2, 3 double bonds. So it's got many double bonds, which means that it's polyunsaturated. Now, because of those double bonds, I've drawn in blue here that long chain, and notice how I've drawn it kind of all bunched up in a kind of curly way, and that's because wherever there's a double bond, we end up getting a kink in the chain, and so with those two molecules that I've drawn there in blue, the bonds that form, remember those are intermolecular forces that I've shown in red there, those bonds are what will bond the two molecules together, and the strength of those forces determines whether it's a solid or a liquid. And because these molecules bunch up like they do, they have a very small effective surface area. And you remember from our work on melting points and physical properties, a small effective surface area means that there are weak intermolecular forces. A reminder, in this particular case, because it's a hydrocarbon, those weak forces are weak van der Waals forces. And so, because of those weak forces, we end up with a low melting point for that particular substance because of the weak intermolecular forces, which means generally at room temperature, these oils are liquids. And obviously, in terms of margarine, that's not very practical. And so, chemists use the process of hydrogenation to try to change that and increase the melting point. So we take one of those polyunsaturated molecules, and through a process of hydrogenation, that's reaction of hydrogen, you can see there in the presence of a nickel catalyst, we then hydrogenate that particular molecule. And you'll see that the product there has none of those double bonds present anymore. They've all been hydrogenated, hydrogen's been added across the double bond, and we now just have single bonds through that particular oil molecule. And if I now draw those molecules, you'll notice that because we don't have any double bonds now, the chain doesn't kink and bend back on itself, and so they tend to be long straight chains. And you'll know from our work that long straight chains mean more intermolecular forces, and that means that each molecule has a much greater effective surface area because it's a long straight molecule now, and that results in much stronger intermolecular forces. They're still van der Waals forces, the same kinds, but they're much stronger. And because the intermolecular forces are now stronger, it means it has a higher melting point. And so those plant oils that we started with, which had a low melting point and were liquid at room temperature, through this process of hydrogenation, we have now increased the melting point, and so at room temperature our margarine now is slightly more solid, and we're able to package it in a tub, and you can use it to then spread on your bread. And so we then say that those plant oils have been hardened through a process of hydrogenation to form margarine. And the reaction was that polyunsaturated molecule reacting with hydrogen in the presence of a nickel catalyst to hydrogenate it and form the margarine that we're after.